In kinetic particle theory, you have been introduced to a way of understanding the physical properties of solids, liquids, and gases. The kinetic model of matter assumes that matter consists of small particles which move in random perpetual motion and which attracts and repels one another. In this video, we will build upon the basic assumptions of kinetic theory into a model for gases. This new model is called the ideal gas model. Let us recall the definition of gases as the phase of matter where particles of a substance are in motion and they fill the container. If we make a few simplifying assumptions about gases, we can make some very easy predictions. The ideal gas model uses the following assumptions. First, particles are in constant random motion. Second, the volume occupied by the particles is negligible compared to the volume of the container. Third, gas particles spend most of the time far apart from each other. Fourth, the only forces between particles is repulsion, and this only occurs during collision. 5. Gas particles can collide with each other or with the walls of the container. When they collide, they transfer kinetic energy. These assumptions are not completely true, but they make the mathematics easy and surprisingly accurate. This kind of samples are called ideal gases. In an ideal gas, there is no interaction between gas particles in between collision. The only forces between particles occurs during collisions. However, in a real gas, the gas particles experience intermolecular bonding and are attracted to each other. In an ideal gas, the volume of gas particles can be taken as zero because the volume occupied by the gas particle is assumed to be negligible compared to the volume of a container. However, in real gas, the volume of gas is not non-zero. The study of the molecules of a gas is a good example of a physical situation where statistical methods give precise and dependable results for macroscopic manifestations of microscopic phenomena. When examining an ideal gas, we want to be able to discuss four variables. Number 1, pressure. This is the force per unit area that the gas is exerting on its container. Number 2, temperature. This tells us how hot or cold the gas is. The temperature has to be in Kelvin. Number 3, volume. This tells us how much space the gas takes up. And number 4, number of moles. This tells us how many particles of gas there are in the container. These variables depend on one another, and the relationship between these variables can be simplified in a single equation known as the ideal gas law. The pressure, volume, and temperature calculations from the ideal gas law are very precise. In the follow-up computer simulation activity in class, we will see how changes in one variable affects the other properties of the gas.